4 to 5 times the strength of 316 as a sort of commodity grade, and that strength is one of the primary reasons why it's used.
In today's technical corner, we're going to be talking about material. This very high strength stainless steel material. Rodney, the metallurgical expert from Langley Alloys, has lovingly brought us quite a heavy component here. We're going to talk a little bit about what it is a little bit later, but first of all, what is this stainless steel we're going to be talking about today?
Well, firstly, I'm a bit concerned that you're calling me an expert. However, I'll let it ride.
I'm afraid it's true, Rodney.
So, today we're going to talk about Fermonic 50 high strength, sometimes known as Nitronic 50. It's a high strength special stainless steel, 4 to 5 times the strength of 316 as a sort of commodity grade, and that strength is one of the primary reasons why it's used. But it has great toughness at low temperatures, and that somewhat informs the applications it goes into.
Absolutely. So 4 to 5 times the strength is huge. It means you can really reduce, I guess, the size of the components, the size of wall thicknesses. But you mentioned cold as well. Now, how does cold normally affect toughness of materials?
If you were talking a regular carbon steel, once you get below minus 30, minus 40, minus 50 degrees centigrade, then they go from being very sort of tough and having that great strength to being brittle and on impact breaking relatively easily. This grade keeps that toughness all the way from room temperature all the way down to sort of cryogenic minus 200 degrees centigrade temperatures.
Wow, and to minus 250 is pretty unimaginable. Those kinds of temperatures, how exactly does it achieve that same strength at such low temperatures?
Well, that's down to the composition, what it's made of, and how it's manufactured. Both of which, have their tweaks, that have been developed over time to get that strength and toughness together.
Yeah, absolutely. So 4 to 5 times the strength, and also that strength than 316, and that also down at ridiculously low temperatures. Now, you've got a component. It's got some flats on it. It's got some precision diameters. What is it? What's it for?
This is a very traditional application for this grade. It's the stem from a valve. So Fermonic 50 will be widely used for valve trim and stem, but also things like subsea connectors and couplings as well. It's where you need that strength and toughness at low temperature. Now, what do I mean? If that's the stem of a valve, and the valve may have been left open or closed for a long, long time, some poor person's going to have to come along and try to actuate it, open or close it, and the valve maybe is sticking. It's maybe in a cold part of the world, or more likely, the liquid that's being pumped through it is also very cold.
And we're measuring, a ball, it might be here.
Yeah,
that's
absolutely.
got a hole in it that lets the fluid through.
And a big handle or actuator at the top. And you're going to have to try and open the valve.
Right. Unlike we've all tried to open a tap or unlock under the sink a little valve that's stuck.
Yeah, but imagine a valve that's maybe 50 or 100 times bigger than your kitchen sink, and the loads and the forces that stem is going to be under.
And that explains why you need kind of 4 to 5 times the strength of 316, but it doesn't explain under the sea, not minus 250 degrees. Are there other applications where the strength and the temperature range make sense?
We're starting to find more and more. So for an alloy that's been around for quite a few years, all of a sudden we're discovering some really interesting applications for it. One of them is to do with the way this product's actually made. So the length of the bar is not restricted to the size of the heat treatment furnace in which it's produced. So a normal bar for us would be no longer than 6 meters, but we can make this in 12 or 13 meter lengths. And we have one particular customer that's exploiting those really long 40-foot bars for their application. But the other one is way more exciting. It's hydrogen. Lots of chatter about the hydrogen economy. But much less knowledge of which metals are suitable for a long-term exposure to hydrogen. One is 316L, which is being used for the majority of parts and components going into this sort of emerging hydrogen industry and technology. But strength is a problem. So if you're now developing and designing high-pressure systems, you need a much stronger alloy. And we've got customers that are already using this. And we're working with others to try and find a solution, a material and a set of properties and size and availability that suits them and opens up these new markets.
That's fascinating that you're one of the only ones who can do those lengths, but does that change the way the material reacts or its properties?
No, the properties are consistent irrespective of the length. It just creates some additional logistical challenges, handling 13-metre long bars, being able to load, unload, turn and manipulate them.
Yeah, don't want to be driving a 13-metre bar down the motorway.
Well, it's just about the limit of what you can put on the back of a truck, to be honest. But when it comes to processing and handling it, yeah, it's a little bit more awkward, shall we say.
Yeah, absolutely. And the other application of hydrogen high pressure vessels, you can imagine using a standard commodity material, which would be really nice to pick. I guess if you're working right in at the boundary of what's possible, then you're gonna, sometimes the designs just wouldn't be viable unless you had a very specialist material like this available.
Certainly the people that are coming to us are looking for something that's compatible with hydrogen, but will also suit these very high pressure new emerging applications and technologies that they're designing. So it's one of those times where the manufacturer, the end user, actually wants to talk to a material supplier and have that two-way dialogue.
Yeah, absolutely. So if you need a high strength stainless steel, just for oil and gas, subsea valves, or if you're working in emerging applications, hydrogen, make sure you check out Fermonic 50 high strength from Langley Alloys.